chapter 11. I can close it down definitely tomorrow. And then do my little bit with chapter 9. Like I said, that may overflow into Wednesday, maybe just a half an hour on Wednesday to finish up everything. And then we use the rest of the time on Wednesday for nothing but a review. Also, Mr. Parks is going to do something for us on tomorrow. Okay, yeah. Guys, any quick questions right now? Now, please tell me at this moment, I know that I just started this, sequences and series. Use that word series here shortly. Sequences. Is this a little bit better than trig? A little bit better than logarithms? Is it true? I would think it's a relief. Just look at a function it's going to come up with for a sequence, a particular term or a summation. Now, what I do need to do though, and I think all this is on your handout. I think I'm finding into the handout here. Let me start out part 1 with this before I jump into everything else. Part 1, here we go. Who gave you this information? Before I get back into where I should be. I'm going to give you that the first term of a sequence has this value. And I'm going to give you the formula. Like we've been guessing at formulas earlier, I'm going to give this one to you. And it's written like that. Now please find or write. Let's write the first 5 terms. I think it'd be a good place to start, and then we'll go into the summation. So guys, keep in mind what I give you. I gave you the value for the first term in this sequence, and I'm asking for the first 5 terms, and I even gave the formula to you. It's written a little differently, but it's a formula. So guys, I'm looking for, and I'll make room for this. Do this, and my first term is -2. I'm looking for the other 4 terms. Now, does anyone have an idea? And I gave you the formula.
A2.
Okay, A subscript 2 is missing. Now here goes. This is A subscript 2. It's missing. And I think by the formula I gave you, here's the formula. It says use this formula, n plus A subscript n minus 1. Now be careful. N in my case is 2. Plus A subscript n minus 1 is 2 minus 1. I'm looking for the second term. Just replace these n's by 2. And I get a formula to you. If I simplify this, this is 2 plus A subscript 1. And thank goodness they gave me A subscript 1. A subscript 1 was given to me as -2, so this says 2 plus, here goes, I'll put it in parentheses, -2. And finally add those up, I think the next term looks like this. 0. Now, third term. I'm going to space here, guys, move it on the side. Look for this term right here. A subscript 3. Thank goodness the formula's been given to me. Here it is. It's n, in my case 3, plus A subscript n minus 1, 3 subtract 1. Comes out to be 3 plus A subscript 2. Now, do I know what A subscript 2 is? Yeah, I just discovered that was 0. So if I put a 0 in there, 3 plus 0, that tells me my next term, if I have no mistake, is 3. You guys agree? Yes or no? Okay, don't let me make a mistake. Fourth term coming up. Marina, the fourth term, my formula, here it is n, 4, plus A subscript 4 minus 1, that's 4 plus A subscript 3, and that's 4 plus, and A subscript 3, if we have no mistake, is 3. And that all together will give me a what? 7? Yes or no, guys? Don't let me make a mistake. And the last term, if we have no mistake, the fifth term. My formula, there it is, n5 plus a subscript 5 minus 1. I'm looking at 5 plus a subscript 4, and that's 5 plus, if we have no mistake, a subscript 4 in the fourth term came out to be a 7. Add them up, looks like it's a 12 if there's no mistake. Guys, do you agree? Based on what was given to you. That those are the terms that we're missing. Yes?
So for the first one, if you, why is it not a negative?
I got you. I see right now. Hang on, Chief, I see what it's saying. You're saying, Professor, guys, erase that. See, that was my first term too. Did I have a negative 2 at first? Yeah, I think I used a 2 throughout this, didn't I? Okay, erase the negative sign. That's me, I'm going down, should not have done that yet. Okay, now does it make sense now with the 2? Gee, thank you. I had a negative 2 at first. We'll bring the negative 2 back in. Now with the 2 there, that's what I work with. Do we agree with those numbers? Is that my sequence? If we have no mistake, and I just hope to goodness we did not. Gee, if this is a negative 2, this is what it's leading to. We'll accept this one. But now, here's what I was after. Suppose a subscript 1, the S is a negative 2. Guys, do me a favor, just make sure that your notes are good. I jumped in too fast. This one we just did was assuming A1 was 2.
But then if you add,
Got
you
you.
added a negative 2 to it when you got it to add up to 0 though.
Down here.
Yeah.
And then we did what? I think I got 0 up here. Is that true, guys? If I use the A1 to be a 2?
Because if you use a positive 2, does it have to be does the 2 where the A is there have to be a positive 2 instead of?
Yeah, I up here, that's why I'm asking you to make a change here. Make this a 2.
Okay.
I'm gonna redo it with a negative 2.
Okay.
It's gonna be a different sequence.
Why right now is it a negative 2?
I got you. Hang on. I'll come back. I'll switch with that. Okay, guys, let's assume that first term is 2. I got ahead of myself. Now we're going to do, Gia. We're going to redo this. Yes. And we'll write the first 5 terms. The first term should be negative 2. Here we go. We've got negative 2, and then we have 1, 2, 3, 4 missing. Second term, this is what you was talking about. Guys, the second term now would be based on what I really wanted. Formula stays the same. Oh, right, here it is. N, in this case, is what? 2 plus a subscript 2 minus 1. And I'm going to end up with 2 plus a subscript 1. Is that true? A subscript 1, Gia, is now negative 2. Simple problem. Now if I put a negative 2 in there, I think I get a 0 here. Is that true? Now the next term, third term. The third term, by formula, right here staring at me, is 3 plus a subscript 3 subtract 1. That's 3 plus a subscript 2. Is that true? Is that written out correctly?
Yes.
Okay, here we go. So that's 3 plus a subscript 2, if I'm correct, was what, 0? Is that true? Do I get a 3? Yes or no, guys?
Yes,
Okay, now I'm jumping back over here and making, was that, so far, I think I used a 2 here to begin with. Is that okay so far or not? Or back here, I switch it to you. Are we okay on this? Ooh. Now keep in mind, this is the first term. Is this the second term, guys, by the formula? The second term says take what? Where is it? Where's my term here? N 2 plus that. Is that true? Before I see some looks like, whoa, oh. Is that written correctly? You think it's written correctly so far? Now, I know what you're looking at, I know exactly what you're looking at, I'm gonna take your question there in a second here. Let me find one more term here. We think it's 3. Fourth term. Fourth term, by formula, should be n, in this case it's 4, plus a subscript 4 subtract 1, that's 4 plus a subscript 3, and if we have that right, that's 4 plus 3, was it? And I'm stepping aside here to look at it, is that 7? Yes or no, guys? Is it? Does that work like that? I know what, gee, I bet I know what you guys are thinking about. I bet you're thinking about this. You're probably thinking about a subscript n, where I have in there just n. That might be what you're thinking about. By the way, do the terms look agreeable with you based on what we're doing here? Okay, now, let me do this, Gia. And I bet I'm going to answer also other questions here. Let me do this right quickly. First term is -2, we'll just write a couple here. Let's say it was this. Let's say a subscript n is equal to, here's a good way to do it here, a subscript 1 plus a subscript, let's see if I write this out. A subscript n equals a subscript n minus 1 plus this. That's supposed to look like that. That's right, 3 terms out. -2 is my first term. That's right, it's just a few of these guys. Second term, a subscript 2. If I follow the formula, replace n by 2, this becomes a subscript 2 minus 1 plus a subscript what? 2 minus 2. Is that true? Now what would be the problem here? Does that become a subscript 0? Which I can't deal with here on this one? Is that true? But it would be a subscript 1, which we can find up here, a subscript 0, and you say, Professor, gotta stop at this point because I don't know what a subscript 0 is. I think Gia and other students, I don't know. Well, I think it's this right here throwing me off. It's not a subscript n, it's just n. I think that's what's throwing you off. Is that true? Was that what it was or not? Whoa. Did I answer your question or not? See it now? I think some students may have thought this was a subscript n, which would make a difference. But it's going to be n to work with, wherever n was. So back here on my second term, of course, n is 2. And here, n is 3. And n is 4. Does that help? Okay. Woo! Phil, make sense? Will you work these terms out? I gave you a string one there to work with, a sequence of those strings to work out. Okay, guys, with all that said, I thought I'd do that. Thought about it at the break. I should show you something like that. Now, let me erase this. Just want to point something out before we move on. Now, what they're going to ask us to do, after all this business here, let me leave that there. That did not mean that. Okay. Let's call this part 2. Yeah, finally, we're going to do this. Now take those terms and sum them up and get a graph. We use this symbol for math, from the Greek alphabet, summation, sigma. That means this. I'll do that right here on the side here. So if I see that, along with what we're doing already, that means now don't just list them, add them up. Now, Mr. Gauss, his problem would look like this if I use the sigma summation to show what he was asked to do. and I'm gonna do mine with an N. He was asked to start out with 1, go through 100, N. That's what you saw before the break when I took 1 plus 2 plus 3 plus 4 all the way through 100. Guys, if I do it here, you said, Professor, what does that mean? You always start at the base. Well, replace by 1 at the base inside here. This is your formula. So if I replace n by 1, I get 1 like he did. Then put a plus sign since it is summation. You're adding. Now replace n by 2. Go 1 step higher. Replace n by 2, you get a 2. Replace n by 3, you get a 3. And you keep this routine up until you reach the top, where you finally replace n by 100. And it looks like that. So we'll start at the base, build all the way up to the top, and use inside there whatever formula they give me. And this was Mr. Gauss here. And he already figured this out for us. This was 5,050. Now, though, that was pretty easy with his help. Philip, since you're nearby, did I have placed there, I know I do have my hand up here, did I have placed there some summations to maybe try to find the answers for with the sigma notation? Okay, read the first one for me, and I'll go ahead and put the sigma, get ready for it, the summation notation, and ask for your help here. Tell me where they started, where they want to end, and what formula did they give inside? At the base, what was the base? They want to start at 1? Did I give some of those guys or not? No, I don't want that one. Did I give something besides that? On that particular handout? We did Mr. Gauss, I've already done that one. Was there something else?
That is long without C.
Ah, beautiful, beautiful. I just wrote it out and you guys did not see sigma there written, right? Beautiful, hang on. I see what I did. Now, Rena, since you're close by, tell the class, now this is right here, tell the class what on the handout was I asked you to find the sum of. Hang on. And then we'll rewrite it and then try to find the sum. What was it?
Find the sum 2 plus 5 until 41.
Wait, 2 plus?
2 plus 5 plus 8
Uh-huh.
plus dots plus 41.
Plus
41.
4,
41.
401?
41.
41? Gotcha. Oh, Ramsey, you didn't. I jumped into this. Geez, that's when I ease into it. What was I thinking when I constructed this handout? I'm looking at my notes, and then I'm looking at you. When I passed out to you guys, I jumped into it. Gee, I need some big time help here. This sort of ties in with what she was talking about. Guys, there's what they want you to add up. I want to rewrite it using sigma to show the same thing. So I am going to start out with the base here, 1. Then I'll have to decide where I want to stop, and then place something inside there to generate those numbers. And my numbers are 2, 5, 8, so forth and so on. Now, before the break, I first now need, oh my goodness, I didn't. You're going to come up with, before the break, we were discussing this. Does anyone have a formula in mind, or what's in anyone already, that would give me 2, 5, 8,
N plus 3.
and all the way down to 41?
3n minus 1.
Hang on. Now, before the break, to make things connect for me here, if I replace n by 1, which we always do first, I get 2. That was the first term. If I replace n by 2, the second term, I get 5. N by 3, I get 8. Beautiful. That's my formula that goes inside here. Nice. It is working out. Now, what's missing right now, we don't have the answer for it, but what's missing right now on the summation notation of the sigma? The top. Where did it wants to stop? Mr. Gauss stopped at 100. Where do I have to stop? Well, I gotta do a little figuring here. Whatever number you give me, when I replace it in that formula that's given to me, I better get 41. Does anyone think they know the number at the top there, the stopping place? And one way to check it is, this right here, when you give it to me at the top, and I check it by formula, I replace in by that number, you get 41,
14.
or 14. 3 times 14 is 42, 42 minus 1 is 41. Now you have your sigma summation completely established. I don't have the answer to it right now, but at least it's been established.
Why the base is 1?
You always start with 1. In order to use what I'm coming up, I'm giving you guys some formulas. I can't use summation formulas unless the base starts with a 1. Now, can the base start with a 2? Good question. Or 3 or 4? It could. But you have to modify what I'm doing here. So I'm gonna have mine start at 1, so you guys are allowed to use those formulas. It's coming up. Guys, make sense? Now let me write out, here we go. If I replace n by 1, right here, in 3n minus 1, we get 2, as we said earlier. N by 2, I get a 5. Replace n by 3, I get an 8. And yes, finally, if I replace n by, at the top, 14, I get the 41 that's given to me. Yes?
Is it 3 multiply n minus 1?
It's 3n minus 1. Not like this. You think like this?
Yes.
Not that. It's that.
So when it's...
Now you go out, you wanna remove the parentheses? You can do that.
So 5 multiply 3 is 15 minus 1 is 14, but it's like,
Or if you replace n by 3,
yeah, n by 5.
or 5, that'd be 15 minus 1 is what, 14?
14, but there's 8.
Oh, no, that continues. By the way, since you did mention, put a 5 in there maybe, here we go. So 3 times 5 would be what, 15 minus 1 is 14, let's see if it is. 2 plus 5, I think they differ by 3, don't they guys? 11, is that 14 coming up? See if I'm right, guys. 1, 2, 3, 4, 5, is that the 5th term, 14? Okay. There's the formula. Joan. They want not only the formula, I see what I was doing there on the handout. Well, I jumped into it. Gia, look at this. Put it in parentheses. They want you to add these up. Selena, 2 plus 5, I can do that, 7. Now smile. Then 7 plus 8 is 15, that's not too bad. Then 15 plus, I guess, the next one's what, 11? What's that, 26? Joseph? I can do that. But am I going to go all the way through 41 and try to get a grand total? That's what they want. They want you to sit there, if you have the time, and add them up all the way through 41 and get a grand total, and that's going to be the answer for this summation. I'm looking for one number that acts as the sum. Oh, wow, nice. I set you up. I set you up. Do you think we are going to sit here and add those up directly? You know, no. We'll be here forever. We'll be here forever. So I need a plan, and you guys may have a plan already, and I'll take suggestions, and then I'll give you some help. Let me take here first.
1 to 14 times 41 plus 1 and divide by 2.
Whoa, so you may know something we don't know. Let me put it on the side here.
The
You're
same
saying
as
that,
the
hang on,
first.
you're saying 14 times what?
Well, times 41 plus 1. So
41 plus 1.
42.
Okay, 42.
Divide by 2.
Oh, now hang on. I'm not saying that's wrong. I'm not saying it's correct. He thinks, Professor, do that, and you'll get the grand sum. Hang on. Bill?
I think it should be 43.
Yeah.
So when you add-
43, what, here?
Yeah.
Hang on. and leave the 14 and the, everything else okay. 14 times 43 divided by 2?
Maybe 41 times 43.
Now we're making another change. What's the other change?
41 times 43 divided by 2.
Wait, 41
Times 43.
times 43?
Yeah,
That's 10 more.
divided by 2.
Okay, now, Marina, she thinks it's that.
I was just gonna say 7 times 43, so it's basically the same.
7 times what, 43?
Yeah.
And divided by 2?
Not divided by 2.
Oh, no, not divided by 2, Professor. Just leave it like that, which I think is the same thing as this.
Yeah.
Cancel 2 and 14, get 7. I think it's the same thing. We gotta come up with a plan. You're not gonna sit there and either use a calculator and click and add them all up, or use some type of program of some sort. No, there must be a plan here. Okay, here's the plan. You have formulas. Here's a wait, Professor, more formulas? Lord, having more formulas are there, Professor? At least these are sort of basic formulas. Philip, did you have the handout right there? Did I list the formulas for you? Somewhere on that handout. But we cannot add these up directly each time. Did I give formulas to you or not?
I think, like for the infinity one, but
Yeah, no, it looks like a formula. Did I give you anything that looks like a formula on that handout? If not, I'm here. Is that where you don't see it? With the sigma? I maybe some back?
Only for infinite geometric series.
Oh, beautiful, I wanna talk about that infinite geometric series. Where do you see what happens there? Here's the last week, I like this. I'm not only here, everybody won't come up until tomorrow. But I did not give you directly formulas to do this, did I? Okay, here we go, guys, on the side. These are summation formulas. I'm giving you only 3 of these. Mr. Park. June. I think when I list these, you guys may recognize them from a calc class, that maybe you had to use them somewhere, maybe in trying to find the area of a region, shaded region, or a region caught between 2 curves, something like that. I'm gonna place this one first. Guys, if you're asked to sum up, and your textbook wrote it out like this, k is equal to 1 through n of k. That's where your textbook presented, so I'm gonna present it the same way. And then they give you a formula. If your summation looks anything like that, you may use this formula. Now, what formula is it? They're saying it's this formula. I'm gonna accept the formula. Now, before I fully accept it, can anyone tell me, just out of curiosity, you know how I teach, so I make connections here. Let's write a few of the terms out that this summation is indicating to me. Let's write a few of those terms out. If I let k be a 1, is that true? It's 1. If I now go up to 2, replace k by 2, it's 2. K by 3, 3, and this says go all the way out until you reach the top, which is n. That's it, what it means. You start at the base and you build up to the top. Start here always, and like Marina, you were asking earlier, Professor, could I start with at the base 2 or a 3? You could. But if you want to use one of these formulas coming up, you have to start with the base to be 1. And go up to the top where the top is, and they say if that happens, you may use that formula. Guess what? This happened for Mr. Gauss. Let me jump back to Mr. Gauss. Did I place Mr. Gauss on the board here? Maybe you erased it?
it's 100, 100, 1 divided by 2.
Yeah, what if he has to do this? I'm gonna use a K here. I think at the top, he was going through 100. The true, guys? And then we saw what Mr. Gauss did. He added forwards and backwards and did something to it and got the answer. But now the formula says if you want to use it, you get the answer right quickly by using this formula. Now he got 5,050. My formula now says n times n plus 1 over 2. What is n in my case? 100. So it's 100 times 101 over 2. If I apply this formula. Is that the same thing we were talking about right before the break that Gauss did? Is that true? And then a little canceling here. It's 50. 50 times 101 is 5,050. That's what Gauss was doing. And now there's a formula for it. N times n plus 1 over 2. But it's got to look just like that, Arena. Very good point you made. It's got to look exactly like this before you use this. You've got to start with 1, not 2, not 3 down here at the base. Top is open, and then use an N. And then inside here, they'll give you a formula, K in this case. That's got to look just like this before you use that formula. Okay. Number 2. Next formula I'm holding you responsible for, like I said, there's only 3. Is this one. Mr. Park, June, this might bring back some fond memories, I don't know. And when you had some calculus, maybe I'd use a summation of some sort and do it. Okay guys, let's do it. Let's start with 1, go through n, and in this case I got k squared. Not k, k squared. Now let's write a few of the terms out, see what they look like. And then see what the formula is if I want to sum them up. You guys will write a few of the terms out. Let's start with 1. I'll put a 1 in there, 1 squared. It's like this, which is 1. Put a 2 in there, 2 squared. 3, 3 squared. And it says, please continue doing this until you reach the top, n squared. Now, if I ask you right now at this point, that you're watching here, can anyone tell me the sum of the first 3 terms? What's the sum of the first 3 terms? I got 1, just out of curiosity, 4, and 9. Is that 14?
Yes.
So the first 3 sum up to 14. So I'm assuming if I start at 1 and stop where 3 on this, the sum should be what, 14? If I ask you to add up the first 3? The trouble is, here goes, Selena. If I put 100 at the top, Mr. Gauss had 100 on his. I suppose I placed 100 here. And asked you to add up the first 100 of these types. Oh, no. Are you going to be able to do all that? No. Even if I placed at the top 50, that would be a challenge. 25 would be a challenge. Add the first 25 terms of this K-squared, Professor? No way. First 10 would be a challenge. We could do it. So what do we do? Your textbook says have students do this. Here's the formula. N times n plus 1 times 2n plus 1 all over 6. We're going to test it. See if it works. There's only one more formula. The next formula is the easiest one of all. But this one, guys, looks a little strange. Now, let me do this. Let me write out a few more of the terms here. I got 1 squared, 2 squared is 4, 3 squared is 9. Let's put 4 in there. 4 squared is 16. Let's put a 5. 5 squared is 25. Let me stop at 5. And that would look like this with sigma. You're going to start out with k is equal to 1. You're going to go through 5 of k squared. That's what it looks like. That's it with the sigma notation. Same thing. We're actually going to add up the first 5, 1, 2, 3, 4, 5, first 5 terms. I can add these up, PK, pretty well. I think we all could. 1 plus 4 is 5. 5 plus 9 is 14. 14 plus 16 is 30. 30 plus 25, guys, is that 55? Yes or no? I did that quickly. Is it 55? So, Philip says the first 1, 2, 3, 4, 5, the first 5 terms should sum up to 55. My concern is, again, though, if I change it to the first 100 terms, this was easy. I can do this by hand, just looking at it, just watching. Now, by the way, it's 55 for the first 5 terms. Let's go back, go to this strange formula that I did not derive for you. I just gave it to you. And you replace in this strange formula n by 5. I had better get 55. Just for a little check here. So guys, the formula says 5. 5 plus 1 is 6. 2 times 5 plus 1, is that 11, guys? All over 6. Is that the way the formula looks if I replace n by 5? These will cancel. And what is 5 times 11? 55. So rather than me standing here and adding them up, Zoe, we're going to use the formula. And what formula is it? I know it's a strange looking formula. If you're trying to add up something that takes this form, a k squared, this is my formula. June, Mr. Park, do you guys remember, did you have to use the summation of k squared anywhere in the calc problem? So yes, he had shaking yes. Now, did that professor just give it to you and say you have to use this formula? Or did they discuss the formula a little bit with you or not? Or do you recall?
I think they just assume, you know.
Yeah, they assume that when you move from this class to the next class, you should know this. Okay, Phil, that's the second one of the 3 formulas I'm responsible for. Okay, number 3. Hang on. My last one. Your textbook shows to write it like this. Summation. Arena, here we go again. Always start with 1 at the bottom. Go through n. And now they're saying know how to deal with this as your last formula. C times n. You know what? Let me do it's better. I don't want that right now. Just C. We'll do something else. Just C. What do you think that means? First, before I talk about it, they're asking you to add up something, and they're calling it right now just C, not K, just C. Wonder what that means. Reading math it's not easy sometimes. You might have an idea what you might say that means. You say, Professor, where's the K? This one had a K in it. This one had a K in it. And you start with K is equal to 1 at the bottom. Professor, you still start with K is equal to 1. Where's my K? The K's missing on this last formula. What do you think they're asking you to sum up here? Any ideas what that C might represent? It's a word. What do you think C represents? Coefficient? Yeah. Complex? Yeah. Very good. Constant? Rita, she said, Professor, I think they're asking you to sum up a constant. Now, what on earth does that look like? Here goes. Summation. We'll start with 1. Let me replace the top with a number to make more sense of this, guys. We'll put it maybe 25 at the top. And inside here is 6. She says, put a constant, Professor, inside. Just a number. No variable with it, just a constant, no variable. Now, can anyone tell me, does this, at this point for the example, does it mean this? 6 plus 6 plus 6 plus 6. And they have 25 terms. Yes. That's what it means. You're adding a constant each time. This one's not too bad. I think you guys can tell me what that grand sum is. What is 6 plus 6 plus 6, 25 times? 150, and a quick way to get it is, it is 150. There you go. Philip, oh, Professor Boyd, just multiply those two together, you got 25 sixes. So 25 times 6, and I think he's telling me what was 150? And there's your grand sum. That's the answer to this. This is all equal to 150. Now, this is what the textbook probably shows for a formula here. Yes?
C times N.
Yeah, absolutely. Just multiply the two together. That's your formula. That's your formula for summation of a constant. And number of times. Now you have all three formulas I need. We've done some work today. All three formulas. What's my time here? We'll try maybe one problem with you, then I need to discuss a few things with you. We got time.
Actually, can we go back to our?
Go where?
First one.
Oh, back here.
On the previous one, yeah.
Oh, which one? Oh, this right here?
Yes.
Oh, you mean we didn't finish it up?
No.
Oh, we're gonna finish it up.
It's
We'll go back.
14.
Oh, we'll go back. Now, I think I wrote a few of the terms out. I replaced, rather than K, I used an N. I replaced N by 1, I got 2. Replaced N by 2, I got 5. Replaced N by 3, I get an 8. And finally, you guys said put a 14 at the top. I did, that gives you a 41. Is that true, guys?
Mhm.
But we have not added them up yet. Now, there's some help. Since I've already had this discussion here, you gotta be careful. Does anyone have an idea how I may apply that over there to this and get the sum of this? Grand sum. Go for it.
This is the first formula, so we can use 14 on top.
Okay, hang on. So you're telling me, just a second.
It's N.
Let me split this up first. I think I know what you mean. Guys, we'll split this up. That 3 can be lifted out front, which is nice. And it leaves, at this point, this for the first term. I can put the constant out front. Oh, by the way, what did it leave? Did it leave something I used one of the formulas on? Did it give me this formula right here, except they're using a K here? Is it this formula I will apply here shortly? Yes or no, guys? I'm using an N here rather than a K, but that same formula. What else do I have here? Got a minus. Here we go. There's a minus sign. And also you're summing up, I'm in here, 1 through 14 of 1. There's the problem that we stopped at over here. Split up into two sigmas, two summations.
So 1 is constant.
Thank you. Now I can use two formulas. First formula, he's right here. Guys, the 3's out front, you're allowed to lift that out somewhat like an extruded property. That's out front. Now this, I'm talking about this right here.
So
That fits this formula here. It's N times N plus 1 over 2, like Mr. Gauss. So in my case, that's what, 14
times 15.
times 15 all over 2. Yes or no?
Yes.
Then minus, the last one, the way we split it up, looks more like this one. For a constant. And that says what? That constant times N, my constant in this case is 1. And N was 14. Does that make sense?
Yes.
Is that NC by formula? If I do a calculation and not mess up, and please don't let me mess up here on this, I'm gonna cancel 2 into 14, get a 7. Oh, it's still not that great. 21 times 15 is the first term, I think. Does anyone know what 21 times 15 is on this Monday?
Let's say 7.
Oh, no, we're not gonna say, we're gonna get it. 21 times 15.
32.
Here's something else.
315.
315? I
Yes.
did that real quick. Okay, 315, where am I? 7 times, that's 15 times 21. Okay, 315. And then on the end, subtract what? What's this right here? 14. Answer looks like it's 301. Yes or no? those formulas will come in handy. Now, if you're sitting there, you got a little time left over on your test, you say, I'm gonna go back through and check a few things here. And you go to this problem, guys, you could, it probably wouldn't take that much time, you could directly add all these up. Be patient. All the way through 41, and BK, we're hoping when you get, add them all up and you don't make a mistake in your addition, you hope to get that. And that would be a way to check it with the help of the formulas. Yes?
Which one of those formulas on the left would it be?
Which one is that gonna be here, guys? 21 times 15. Did we get 21 times, was it 21? 21 minus 15. Oh my goodness, which one would that be? This is 21 times 15, then this is subtract, what was this, 14? Phil, here we go. You're gonna make me do it. He wants to know, as we were guessing, Professor, who had it right? You said it's 301 is the answer. Which one of these was it? Phil, I have this, oh my goodness. 14 times 15 over 2, and then subtract 14 down here. Okay, looks like the most common answer I got from you guys was all over 2, wasn't it? We put all this over 2. Oh, geez, guys, help me out here. 14 times 15. Does anyone know what 14 times 15 is? What's 14 times 15? That'd be
100.
How much?
210.
Don't mess me up. That's 210?
I think it's.
No, don't even mess me up. Is it 210? 190 for 14 times 15. 190, okay. Times 3. So 190 times 3, my goodness, Phil, look what you did. 190 times 3, what was that, 570? Is it? Is it 570? I think. Okay, 570 over 2. I'm just trying to see what matches up here. Subtract 28. Yeah, nope. Is it gonna work here? Yeah, 28 over 2. Go, got me into it. 570 subtract 28, what's left?
I'm not sure if it's only 190.
I don't know either. 542 over 2? Jeez, you guys get it like this. Maybe one of these does work. I got 542 if I made a mistake. Over 2.
210 is correct.
Yeah,
It's not
14 times
190.
10.
Is it matched up with one of these?
14 times 15 should be 210.
Oh, wait, where was it?
Just in the beginning, 14 times 15.
Oh, right here.
Yes,
How much was that?
210.
210 times 3, what's that, 630?
Yeah.
Here.
No,
Yeah. Who gave me 5 for the other one? 630. Then subtract 28, what's left? 602. Yay. Bill, I'll remember you for this. 602. Now, which one of these is the answer? 14 times 43, if 14 times 43 is 602, the person who gave this to me earlier matches it up. Is 14 times 43 602? Does anyone have a calculator? Oh, it's too late to do this on the board. Or some,
14 is square.
Wait a minute.
And into 7 times 30.
or is it this one? And I think this one's too large. This isn't too large? Is it this one? You think this times this is 602? On top? If it is, the person who gave this one to me, 14 times 43, I hope it's 602. If it is, this is the response that was correct. Okay. Now, we're going to just sit there and guess at more and more and more. No, I led you into it. What am I going to do? You are going to do. We're going to use these to get the answer. We're not going to just sit there and guess, but whoever gave that guess, who gave me this guess, by the way? Who gave this to me? It worked. That's why he wanted me to check it. You got it right. Okay, and we did my formula and it checks out. Now guys, I see I got 10 minutes left. Now, hang on. And I want to overwhelm you with all this. Tomorrow, I gotta pick up where I left off here. Then go into your handout and get this chapter 11 finished, which I can do. Tomorrow's Tuesday, right? And then if you flip it over, you'll say, Professor, that's all we need to know about chapter 9? Because I think chapter 9's on the other side. Right? I think. Is there about chapter 9 down there? Somewhere. Okay, don't scare me. Yeah, it's on there somewhere. And then I'll finish the course out. Yeah. You check that out and feel better right first. Guys, I know I threw a lot at you. Plus, Mr. Parks will take a chunk of time with his teaching tomorrow. Wow. June, again, what she sends out in color